Okay, so let's say we want the moment of inertia of the sphere about the z-axis. What's the moment of inertia of a typical increment? Just the mass times the square of the distance from the z-axis, mr squared, just like it was when we did the thing in the plane last time. The mass is density times volume. I'll abbreviate square of distance because we don't have but 2 minutes left, okay? But that's all it's going to take, okay? Rho evaluated at the sample point times volume right? That much is straightforward. Now if you've got the rho function, if it's constant of course, then it's just going to be whatever that constant is, right? But it doesn't matter whether it's constant or not, you can write down the integral. If you know what this function is, you can write down the integral. Sometimes you got to figure out what that function is, but you can do that, okay? So, and then you have your volume, right? And what's the square of your distance from the z-axis?
Is this in rectangular?
We're in rectangular coordinates, yeah.
Okay, so.
And now if we were in cylindrical, it'd be really convenient, and that's where you usually want to do it about an axis, okay? Because this would be r squared, okay? But what is it here?
X squared plus y squared.
And we want to use the i's and the ij's to keep track of where we are. Sometimes that's really important. You can often slop it over, but don't. Okay? So what is our integral then? Well, the limits in the integral are just what they were, negative r to r, negative square root of r squared minus y squared to the square root of r squared minus y squared, negative square root of r squared minus x squared minus y squared to the square root of r squared minus x squared minus y squared, right? Of what? Rho of x, y, z times x squared plus y squared dz, dy, dx. Here's z, here's y, here's x, right? So for homework, one thing I'm going to ask you to do is just figure out the moment of inertia of a sphere of mass m, radius r. You get the density, you divide the mass by the volume, okay? Of course, first I'm going to ask you to integrate to find the volume of the sphere. Just leave all this stuff off and just do this integral that we already wrote out, right? And then I'll assign you some stuff from, the rest of the textbook or something. Fair enough? No, not if I do the whole rest of the textbook, but yeah, I'll keep it only semi-unreasonable.